The study employed several assays to assess oxidative stress and DNA damage, including the T-bars assay for lipid peroxidation, alkaline comet assay for single-strand DNA breaks, and formamidopyrimidine glycosylase (FPG), sensitive sites assay for oxidatively generated DNA damage. These methodologies provide a robust framework for detecting oxidative stress and genotoxic effects, lending credibility to the study's findings. Exposure to RF-EMF and chemical mutagens can lead to excessive production of ROS, resulting in oxidative stress. This condition increases the risk for chronic diseases and has been suggested as a key factor in the RF-related incidence of brain tumors and childhood leukemias. In summary, the document underscores the potential genotoxic effects of chronic exposure to RF-EMF, highlighting the role of oxidative stress in mediating these effects. The findings align with broader research indicating that RF-EMF exposure can induce oxidative stress, leading to DNA damage and chromosomal aberrations, which are critical pathways in the development of various health issues, including cancer. The study documented exposures to various electromagnetic fields, EMF, focusing on frequencies and power levels from mobile phone base stations, MPBS, specifically GSM 900 and LTE signals. The physical parameters measured in the participants' sleeping areas include low-frequency electric fields, LFF, and low-frequency magnetic fields, LF-MF. These were generally low and not significantly different between the control and exposed groups. The study aimed to document the exposure specifically from MPBS signals rather than these low-frequency fields. High-frequency RF-EMF. The high-frequency range was documented using frequency-selective measurements of individual radio services. The equipment used could measure frequencies from 9 kHz up to 6 GHz, covering the spectrum of GSM 900 and LTE signals emitted by MPBS. The exposure levels to GSM and LTE signals were significantly different between the groups, with the exposed group living closer to the MPBS and experiencing higher levels of RF-EMF. The control group had GSM exposure ranging from 0 to 45 UWM2 and LTE exposure from 0.1 to 77 UWM2. In contrast, the exposed group had GSM exposure ranging from 71 to 2958 UWM2 and LTE exposure from 540 to 8040 UWM2. These findings highlight the range of RF-EMF exposures that individuals living near mobile phone base stations might experience. In real-world scenarios, such exposure levels are likely encountered by individuals living within close proximity, under 200 meters, to MPBS. This contrasts with those living farther away, who experience significantly lower exposure levels.